All right, first module of Unit 5. Let's get started. We're going to be identifying factors and graphing zeros. So we've already had some experience with factors, with quadratics at least. Now we're going to experiencing it with multiple polynomials. So this can go higher than power 2. Graphing zeros. These are just x-intercepts. So let's get into the actual lesson. Might have to do a two-parter, but last time I was surprised at how fast we were able to get through the slides. So the objective for this lesson is to analyze polynomials, apply remainder theorem, and identify zeros and factorizations in real life and complex forms. So let's get into the lesson. All right. So the idea here is the idea of zero product property. Now, if we're saying that A times B equals 0, but A doesn't equal 0, B has to equal 0. There's no way around it. So let's say we have something like this. If we're going to factor something out here, so what we're going to do here is just factor out these terms. So let me get down to here. This is what's known as zero product property. If one of the terms is 0, the other one has to be 0. So if you notice here, they're factoring out a 4x squared. So if we list out these expression here, give me a second. I don't know why it automatically logs me out here. Let me exit out of there. If we list this out, we're going to do what's known as factor by grouping. We're going to grab this here, going to leave some space, and you'll see why I'm leaving space in a second. So I'm going to factor out a 4x squared from these first two terms, and I'm getting this x plus 1. And then from here, I'm factoring out a 3, and I still get an x plus 1 because I'm essentially just dividing by whatever I'm factoring out. So since both of these are x plus 1, that's how we can see this here. So that means that this has to be x plus 1. Or, yes, x plus. So that's how we do factor by grouping. What's essentially happening is I'm factoring out this x plus 1, and I'm leaving what's left over in its own parentheses. I don't know why Edmentum always kind of has it the other way. I always see it as you have to factor this, and when you factor, I always take stuff out from the left. So it's supposed to be x minus 1. My pinky just slipped. There we go. Even though I should have used the ring finger for that one. So this is saying, like, if we plug in 5, well, if we plug in 5 into our x's, this is going to be 0. So if it's 0, then everything's 0. It doesn't matter what's inside this parenthesis. 0 times 7 is still 0, so we still get 0. So this is what's known as a 0, obviously. If you plug in a 5 for x, it's a 0. It's our x-intercept. Our y value becomes 0. And same thing with negative 2. Negative 2 plus 2 is 0, so we get 0. And x plus 1. Oh my gosh, I have to redo all of these because I did an x minus 1. I was solving it in my head, going like, oh, the answer is x equals negative 1. So this is x plus 1, 0. Oh my gosh. 0. My mouse is just not cooperating with me. Moving on to the next one. So always, these are very useful to do, but you can always watch these on your own. I'm not into the idea of doing a video within a video. Plus, I don't have the audio set up to do that. Going in, we're going to talk about remainder theorem. So the idea of remainder theorem is, let's say we're able to divide, but we had something left over. What do we do? Well, the idea of remainder theorem is that if we divide, we factor something out, and there's something left over, we're gonna be doing leftover. You'll see that it'll be whatever's left over whatever we divided by, and we'll get into that in a bit. So these are rules that you should be familiar with. Factoring out by GCF. So we take a term, we factor out the greatest common factor. Factoring out a trinomial, so this is the box method, or you can use the X method. Usually what they're showing here is what's known as the AC method. The AC method is the idea of getting the first coefficient and the last coefficient, putting it at the bottom for the X box method, and then putting a term, the middle coefficient on top, and that's going to give us clues on how to factor this out. So if we add these two together, we should get -1. If we multiply them together, we should get a -6. So our answers are going to end up being -3 and +2. If you add them together, you get -1. But if you multiply them together, you're going to get that -3. So this is just them going through the factors of -6. And eventually we get to that point where if you add them together, you'll get that -1. Or you can use the box method, which I've done in my other videos. Trinomials. That's what I was talking about, the AC factoring. It's basically the same thing, except now you're using AC factoring. And you can use that to help you do factor by grouping. So if our factors are 2 and 3, we can split those up, and that'll help us do factor by grouping. So you can see here that we have 6 and a 1 here. That's going to help get us the 5 in the middle. And multiplying the 2 and the -3 gives us that -6. So if we were to add these two, we get the -5. If we multiplied these two, we would get the -3 times -6. So that's this AC method right here. Your A term times your C term, which helps you do the X box method, as I mentioned before. -5 is our middle term. A times C is -6, and then we can combine them using the box method. Or like I said, I meant to say the X method. I always use the box method when solving this. It's always going to work unless you're dealing with imaginary numbers, in which case you have to use the quadratic formula anyways. Factoring perfect trinomials. So perfect trinomials, there's a few cases. If it is a sum, you can take if you take half of this and square it, there would be that. So that's what's causing a perfect trinomial, is taking half of this, squaring it, gives you that perfect trinomial. Going to factoring the difference of squares. This is known as dose. And it's basically the conjugate. One of them has a plus sign, one of them has a negative sign, and because of that, the middle term ends up canceling out. So that's why this is known as difference of squares. A lot of people just call it dose, difference of squares. Going through to the next one, we have factor by grouping. We already went over that. You just kind of if you have a quadnomial, you separate them out, do a GCF. So if you know GCF, you factor that out, and then you factor out the difference. So that's how come this x plus 3 is in both of them. And then the thing was x squared and -2, so that goes in the other parentheses. Because we're essentially factoring out these two, since they're both being multiplied, we factor them out, and we get it here. And then what's left over is going to be here. And then there's the factoring difference and sums. So if you have a doc, difference of cubes, it's basically, they're both the same formula. The only difference is the plus sign and the minus sign. I went over this when I did another video for polynomials, but basically these are just good formulas to have memorized. I feel like now's an appropriate time to go over it. When I made the initial video, I was like, this is a weird time to go over it. The idea of the zero product property I said at the beginning, if one of them is 0, it doesn't matter which one's which. So if A is 0, then that works. If B is 0, then that works. If they're both 0, then obviously 0 times 0 is 0. So let's go over this. So we have a few answers here. What you can do, this one's easy because it's just the opposite. So we're going to get our first answer is a positive 2. And the reason why this is x minus 2. Our goal is to get this equal to 0, so that's x equals positive 2. Now the 9 squared is a little interesting because what happens here is this becomes x squared equals 9. And when you take the square root, when you take it yourself, you have to account for the positive version and the negative version because negative 3 times negative 3 is also positive 9. So we have to account for the positive and negative 3. And then for the 7, that's just going to be x plus 7 equals 0. So we're assuming that we're making each parentheses equal to 0. So there should be 3 of them because we have 3 sets of parentheses. So here's 1, here's 2, and here's 3. So we have 3 sets of parentheses that are going to give us, minus 7. They're going to give us our 3 zeros. And in this case, 4 zeros because we have to account for the positive and negative. Perfect. And then you can see their work here. They're using factories, differences of squares. I didn't use difference of squares, though that is a good point. You can take the square root of x squared minus the square root of 9, so you know that's a difference of squares. So that's another way to kind of figure it out, if you can recognize that. I didn't even see that. I just wanted to show you guys how to solve for it normally using the square root. All right, so we're talking about dividing polynomials. Dividing polynomials is essentially factoring them out, except doing it by division. So this is something I've kind of mentioned before. Factoring is basically dividing. So let's say we have a 3x plus 9. If I factored out a 3, it's the same thing as basically just saying I'm going to divide this whole thing by 3, except now we're going to do it with polynomials. So we're going to do this with x's and stuff. And there's 2 ways to do that. One of them is known as synthetic division. People usually prefer that one to long division. Long division does have a lot more busy work, but it's very familiar if you're familiar with long division. So if you're familiar with dividing, like let's say I have 49, let's say make it 490, 92, and I want to divide by 3, I would put a 1 here. 3 subtract, get a 1, 19, 6. 6 times 3 is 18. Subtract, I get 1, 2. I still have this downloaded thing from when I did the geometry video. And 3 goes in there 4 times. So 4 times 3 is 12. And you get this. And we're going to talk about what happens if you were to have a remainder with polynomials. So that's basic long division. And you can actually do it when doing this. So here's a long division problem. Study this. Oh, I didn't realize they were going to do a long division. So if there's no remainder, you're fine. So normally when you divide, there's no remainder. But if there is a remainder, you're saying there's a remainder 1. And this essentially means that 3 goes into 40 13 times, and we have 1/3 left over. We'll get into why that's important later. Division without remainder, that just means it factored out nicely. Division with a remainder, what we do is whatever the remainder is, we divide by the divisor. So it's like we're factoring this out, and we're doing this long. So check this out for more details, but notice how we have this x to the, is that a 5th? This is x to the 5th power. I don't like how they do this. Honestly, I always shift my answer over here so they line up properly. This is a terrible way of doing it. I don't know why Edmentum is not lining up the constants, the x's, the x squareds. I feel like they just wrote it just to write it. So 4 times x to the fourth, if you multiply that by x, you get 4x to the fifth. That's the whole point of doing this, so these can cancel out. And you have 4x to the fourth times negative 2. You're going to get this negative 8x to the fourth. Since we're subtracting it, it ends up being like a plus sign, which is why we end up with this 5x to the fourth. And you guys can look at this in further detail. If you ever need to practice it, I do recommend looking at this problem. We will go over it on here, actually. Perfect. So what I'm going to do here is I'm going to see if any of these factors. So this one's a nice one here. This is a good example of doing the x method. So the middle term's 1. This is 3. Two numbers that add up to 1 but give us 3. Actually, does this even work? They can't have to add up to 1 but give us 3. Huh. Can't think of anything, so we're going to skip that one for now. Going on to this one should work a lot better. Actually, no, hold on. What are these? What are these? All right. Match the polynomial to the correct quotient. If remainder theorem exists, write it down. You'll use it. Information in part B. All right. So we're gonna. Oh, I see what we're doing. We're dividing these out, and these are our options. Okay. So grab a piece of paper, or I showed the geometry class this. What you can do is, if you don't have paper at home, you can grab either go on your Google, go on here, and you can either use. I like Jamboards. Jamboards is pretty cool. You can just write stuff down in it. I think there's also Google Draw is an option. Let me see if it's on here. Google Draw. We should have it. Sheet go to the. These are other things I have. Yep, looks like Google Jamboards is probably going to be the best choice for you guys. Just go on Jamboards and you can just draw on here. And I'm using a mouse for this. I'm not even using my pen. All right, so let's get into this. I'm not going to use Google Jamboards because it's easier for you guys to see it here. So x minus 3 over 2x to the third plus 4x squared plus 5x minus 1. X times what gives me 2x cubed? So I'm going to say 2x squared. Unlike Edmentum, I like lining these up. It also helps you to know that you're at the remainder territory. You don't need to keep going. So if I do this, I get 2x cubed, and I get minus 6x squared. Subtract this out. That turns this into positive, so this is 10x squared. And then this negative 2x cubed, that cancels out. That's the whole reason why we did this, is to cancel out the leading terms. Now, how do I get a 10x squared? I'm going to have to multiply this x by 2x. So I'm going to line up my x's, 2x, and it's a positive 2x. We're going to bring down this plus 5x. We're bringing that down. So this becomes 10x squared. It should be. That's the whole reason why we did this. And then minus 6x. We're going to do a double minus there. This becomes 11x because negative, and a negative makes a positive. So it becomes 11 minus 1. So this has to be plus 11. So we get 11x minus 3, or minus 33, sorry. Minus 33. Distribute that. Again, this cancels out, and that becomes a positive. So positive 33, so we have a remainder of 32 is our remainder. They didn't mean for it to be red, but that works out because it's our remainder. So the answer I get here is 2x squared plus 11. Why isn't this working? Did I multiply something wrong here? X squared to 2 negative, that turns to positive. No, that should be an 11. 2x squared. Oh, why did I put, maybe you guys saw that before I did it. I don't know why I put, oh, I see what I did here. I accidentally put a 5 because I saw this. I'm like, yeah, it's totally like 2 times 5. It's supposed to be 10, obviously. From there, though, like the only reason I was able to see that is 10x times that. So we know this is here, but it did tell us to write down our remainder, so I do need to write that down. Let's see here. 10. That's going to make this 50x. Or, I'm sorry, 10. That makes this. Let me just erase everything and start over, guys. I'm sorry. So 2x cubed plus 4x squared plus 5x minus 1. We get x minus 3. So this is 2x squared minus 6x squared minus becomes 10x squared. Bring down plus 5. This is plus 10x. 10x squared minus negative 30x becomes a positive, so this is 35x minus 1 becomes positive 35, which is what we got here, obviously. This is 35x. Oof. Give me a second. 3 times 35. 35 times 3. 105. So this is minus 105. The negative makes a positive, so it's going to be 104. So we have a 104 for this. Now, considering that they told us to write that down for part B, I'm going to just go to part B and finish it. 104. Now let's go to the next one. All right, so the next one, this one is even longer. So what I'm going to do here is I'm going to do x minus 3, x to the third minus 6x squared plus 7x plus 6. X squared would make this x cubed minus x squared. Turns this into a plus. So negative 6 plus 3. First, I'm going to cancel these out. Negative 6 plus 3 is negative 3x squared. Bring down the plus 7x. We're going to multiply this by negative 3x. So right off the bat, I know that my answer is going to be this one because it made a multiple choice, but we still need to figure out the remainder. 3. So this becomes negative 3x squared. Negative times a negative is a positive 9x. Subtract it out, I get negative 2x plus 6. I'm going to multiply this by negative 2. And this actually means that there is no remainder. That means that x minus 3 is a factor. When you get no remainder, that means it is a factor. And this is going to go into place later. So this one is 0. All right, and obviously this is the answer, but we do have to solve it to find the remainder. So I'm just going to zoom down here. X minus 3, x squared minus 2x squared minus 4. This right here is going to be x squared minus 3x, negative, negative. These cancel out. That'll make this, oh, this is, where did I put an x squared here? 3. So negative times a negative is a positive. So this is just x minus 4. So I'm going to put a 1 here, positive 1. X minus 3 minus, and the minus minus makes it a plus, so this is negative 1. So the answer I get is negative 1 for the remainder. 1, submit that. What? Negative, negative. Wait, hold on. No, that should be negative. What did I do wrong here? I think I got ahead of myself. That's an x cubed. No wonder how come I had 2x squared. So I was like, wait a minute. Ah, they tricked me. They forgot to give me my x term. Whenever you don't have an x term, make sure to fill that out with this. So this is x minus 3. So this is going to be our x squared, x cubed minus 3x squared. This turns into a positive. This is x squared plus 0x. So this is just x, obviously. This becomes x squared minus 3x. The minuses turn this into a plus 3x minus 4. So this is going to be a 3, positive 3, 3x minus 9. Turns that into a positive 9, which makes this a positive 5. So I'm just going to write these down. This is a 5. Because when I reset this, it's going to make me type them in. There we go. All right, and then you can see the long division process here. All right, so let's say we plug in a 3 into this. Well, according to this, we plug in a 3, we should have a remainder of 104. So this is actually 104. So finding the remainder is the same thing as plugging in that value. So if we're going to plug in a 3 into this one, we end up getting 104. This has no remainder, so when we plug it into this one, which we already did over here, we got no remainder. So this should be a 0. So this is what's known as remainder theorem. If you divide it out, you're going to get your remainder is your answer to it. So this is very useful. Finding these helps out a lot because if you don't want to plug all this hard work in, if you're able to divide it out, your remainder is your solution. So that's what they're going to get at here. Except I didn't want to calculate it out. I just wanted to let you guys know that. If I were to plug this 3 into here, I would end up getting it. So there you go. So briefly explain the observations you did with step A. The remainder of the solution to what we divided. Actually, the remainder of the 0 for what we divided was the solution. That's like I basically use like so many words there. Uh, Basically, this is a solution to 0. The remainder to the solution, the remainder of the 0 for what we divided was the solution of inputting that value into the equation. And the reason why I say 0 is because I'm saying it's a 0 in the sense that x minus 3 equals 0. You guys can use your own words. You say 3. I'll show you what Edmentum thinks is a good sample answer, but make sure you're using your own words, obviously. We would evaluate the function 3 by. So if we're solving for a, you can solve for a by dividing it by 1 minus a. So that's a good way of thinking of remainder theorem. Let's say we want to solve for a, just divide your polynomial by x minus a. And for this one, I'll give myself a 4. Why not? Basically, the reason why I gave myself a 4 was I lost track of things. So I wrote too sloppy and lost track of places. And I think this is even more likely to happen if you don't organize it the way I did. If you do it the way Edmentum did it, that's not organized at all, which makes it even harder to do. Oh, I forgot to answer these. All right, so let's get to it. What do we have here? Oh, I have to scroll up. So stating and using the remainder theorem. So the idea of the remainder theorem is if we want to solve for a, divide p of x, so divide the function by x minus a, and they're equal. These two are the same thing. Plugging in a or dividing the function by x minus a, they're going to give you the same thing. The remainder of this is going to give you the same thing, I should say. All right, so the remainder theorem. So you can read it here. This I think is very useful. The remainder theorem states that polynomial, so anything with like x's to exponents, so x cubed plus blah 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 blah, as long as you don't have like x in the exponent. If as long as x with an exponent, that's what it's saying. So whatever your remainder is, that's going to be your solution. If your remainder is 0, then it's a divisor. That means it's a factor of it. It's a factor if you have a remainder of 0. All right, so going here. So if we were to plug this in, we're going to divide it by x minus 5. Oh, they're just plugging it in for us. And then they're just going to show us dividing it out by x minus 5. We end up getting the same thing. So they're literally just repeating the activity we just did. Moving on here, using remainder theorem in part 2. So let's say we want to figure out a 0. So we just factor it out. And if that's true, if this is a 0, so x plus 7, that should be a 0. So we're going to plug in 7, we get 0. All right, so this will probably be the last activity I do for this video. You guys are going to have to forgive me because I don't have enough time to do the next video. I'll probably record it on Tuesday. I can't record on Monday, so I'm a little bit late to the video. I'm so sorry, guys. I will get this activity done, though. So, all right. So, which one of these are factors? So, if we plug it in a 5, we get a 0. So, it's a positive 5. So, we want it to be negative. Where's another 0? 12. This is a negative 12, so this is going to be a positive. It's always the opposite symbol when it's something this simple. And those are only zeros. So if this is a 1, that's not a factor. This is a negative 4, so we're going to do that here. This is a positive 7, so we're going to do that. It's not a factor, and that's negative, so all of these are not factors. Let's submit that. So basically, it's a factor if when we plug it in, we get 0. Simple, easy. Let's divide this out. So we want to divide this out. What's the remainder of this? Oof. Let's see here. What is the remainder of this? Well, I'm just going to plug it in because why not? Um, I'm just going to plug in a -4. So I'm going to do f of -4. I'm just going to plug in a -4 into the function. And did they give us the function? They did not give us a function here. I wonder if it's this, actually. I'm going to try it. I'm going to see if they literally gave us the same function. And the other one, -3. So, -3. It didn't. So, oh, it would be +3 if we plugged in a +3. Oh, they did it. I'm not going to run that risk then. It would have been interesting if it was. Hmm. Well, let's divide it out. X plus 4. I didn't want to, but I'm going. Oh, I was going to show you guys how to do synthetic division. Synthetic division is a lot nicer looking, I think, personally, than this. I'm just going to show you guys how to do synthetic division. So the way you do synthetic division, especially because this is perfect for synthetic division. So synthetic division, you're going to do the opposite side. So if it's x plus 4, what you're going to do is you're going to do this -4, and you're only going to write the coefficients. So this is 6. Oh, you know what? Just to not confuse you guys, I won't do synthetic division until the show. I realize you guys should get more practice doing this. X to the 4th plus 6x, and I guarantee you guys are going to get plenty of practice doing synthetic division because it is my preferred way to find remainders. This is going to be x cubed, so we get x to the 4th plus 4x cubed. Subtract that out. This becomes negative, making this 2x cubed. Bring down the 7x squared. We're going to make this 2x squared. And you can see what I mean by I line them up. These are my cubes. They're all cubed going down. These are my squares. They're all squared going down. 2x squared plus 8x squared. Subtract that out. I get -x squared. Bring down this -8. So I'm just going to make this minus x, or -1. I'm sorry. Minus. Oh, wait. Did I forget something again? I did. I totally did. That's what I get when I write so tiny. So I'm going to bring down this -6. So this is -x. So I was right. I just wrote too big. -x, -x squared, -4x, x, negative, that turns to a positive, so this is -2x minus 8, and I'm going to put -2. So this is actually a 0 when I do this. So I get -2x minus 8, subtract it out, that makes this a 0. All right, so this is a 0. I really hope the other one isn't a 0 and this isn't just a waste of my time. I'm going to just plug it in to see what the remainder is. So give me a second. Desmos. I'm going to temporarily move this to my second monitor so it's easier for me to plug into Desmos. I'm going to use my scientific calculator. I'm plugging in a 3 since it was -3. I'm going to plug in a +3. So I'm going to do 3 to the 4th power plus 6, 3 to cube power plus 7, 3 squared minus 6 parentheses 3 minus 8. I get 280. So my remainder should be 280. And you can see just plugging it. Oh, they actually did want you to plug it in instead of dividing it out. So there we go. And I use a graphing calculator to solve for it. All right. So if I did this by dividing that, your remainder is R. Which statement shows this? So if I divide this out by dividing, we get the quotient Q R. So in other words, we're going to do P of X divided by X minus A. We get QR plus our divisor is this. So this is the only answer we can get. Let me see this. Multiply this out. Let me see these other ones. Oh, another way of saying it is if we plug in a positive A, we're going to get an R. So that doesn't involve a quotient. I don't know these. Let me take a look at these. Q of A equals 0. I don't even know how that's possible. If P of X and Q of X, if these are equal, what this? Q of X times that. Oh, yeah. So this is just saying if you plug in the factor. So if you plug this times the quotient, that means you won't have a remainder. So if this is a factor, if X minus A is a factor, then you shouldn't have a remainder, is what it's saying. So what? Those had to have been the answers. Quotient. This I know is right. Oh, can't do it the other way around. So if you plug it in and you get 0, then you can't say the other way around. You can't assume it. Or is it both? I'm going to go for both. It makes sense. If it's one way, it should be the other way. And that makes sense. Q. Then Q. Yeah, this one doesn't make sense. If you plug in A into the remainder, the quotient, that doesn't make any sense. All right, so I just forgot. I didn't realize it's an if-then statement, so it works both ways. So basically, this is saying that if it's a factor, plugging it in should give you 0. If you plug it in and get 0, then it should be a factor. That's what that's saying. And this is your remainder divided by your divisor, whatever you're dividing. And according to remainder theorem, if you plug something in, it's your remainder if you are dividing it. Self-evaluation or too many options. Confused. All right. And that'll be it for now. Let me just go over what we learned from that. Up. So this is just a long, complicated way of saying that, like, if you plug this in, if you plugged in a positive 1, you got 0. So that means x plus 1 is a factor. If we plug in a positive 2, we got a negative 24, so it's not a factor. If we plug in x, how are we plugging in an x here? Oh, I see. X minus 0. So that means we have to plug in a 0 because we're subtracting 0 here. There's nothing here. So this is a factor. 0 is a factor. And so on and so forth for the other ones. So you can always plug those in. All right, so that's what we learned from this. And I'll do a part 2. It should be out on Thursday. So this will at least get you guys started on it. I will do remainder theorems. Kahoot. So unfortunately, you won't have all the parts to it, but I will have it out by Thursday, so you guys should have a video on it. Or Tuesday, or should I? Ooh, I might have to do it Wednesday. We'll see. I'll have it out for you though.